Welcome to finding the radius of convergence. So we have a theorem that we can use for finding the radius of convergence. So given the power series in x minus x naught, which is the sum from n equals 0 to infinity of a sub n times x minus x naught to the n. If we let L equal the limit as n goes to infinity of the absolute value of a sub n plus 1 divided by a sub n, then the radius of convergence is given by R is equal to 1 over L. Just a quick note, if L is 0, then our radius of convergence is considered to be infinite. Similarly, if L is infinite, then our radius of convergence is 0. So let's go ahead and find the radius of convergence of the power series given by the sum from n equals 0 to infinity of 3 to the n times n x to the n. So in this case, our 3 to the n times n is our a sub n. So if we want to find the limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n, this means that we are looking at the limit as n goes to infinity of the absolute value of 3 raised to the n plus 1 times n plus 1 all over 3 to the n times n. This becomes the limit as n goes to infinity of the absolute value of 3n plus 3 all over n. And we know if we have the same degree on the top and the bottom for a limit at infinity, we can just take the coefficients. So this is 3 over 1. And so we just get 3. Again, the rule we're using here for limits at infinity of polynomials. Sorry, of rational functions. If they're matching degrees, then we just take the ratio of the leading coefficients. So using our theorem, we know our L is 3. So we know our radius of convergence R should be 1 over L, and therefore is 1/3. Now let's go ahead and find the radius of convergence of the power series, a sum from n equals 0 to infinity of 2 to the n over n factorial times x plus 1 to the n. So again, this is our a sub n out in front of that x plus 1 to the n. So we have a sub n is 2 to the n over n factorial. That means that if we're looking at the limit as n goes to infinity of the absolute value of an plus 1 over a sub n, we are looking at the limit as n goes to infinity of the absolute value of 2 to the n plus 1 divided by n plus 1 factorial all over 2 to the n divided by n factorial. We can rewrite this as the limit as n goes to infinity of the absolute value of 2 to the n plus 1 over n plus 1 factorial times n factorial over 2 to the n. And we have the limit as n goes to infinity. We'd be left with a 2 up top and an n plus 1 down below. As this goes to infinity, the denominator is going to infinity while the numerator is held constant. So this limit should equal 0. So this is our L. And therefore we have radius of convergence R equals 1 over L, or 1 over 0. And again, we take that to be infinity in this case. So this is how we can go about finding the radius of convergence of our power series.